Hi everybody. Today I wanted to give you another example of how to find a function's inverse. Let's take a look at this problem. Find the inverse function, f inverse, which we denote with f with a superscript -1. Find the inverse function, f inverse, for the function f of x equals 2 over x minus 9. Remember to check your answer by computing both f inverse of f and f of f inverse. We're going to do the solution in 5 steps, just like we have done in class. The first step of the solution is renaming the function you're given, f of x, as y. So that means all you need to do is write y equals 2 over x minus 9, because I'm asking you to find the inverse of f of x equals 2 over x minus 9. Step 2, anywhere you see an x, write a y, and anywhere you see a y, you need to write an x. So if we have y equals 2 over x minus 9, then when we swap the x's and the y's, we're going to get x equals 2 over y minus 9. Step 3, this is usually the most labor-intensive step. We have x equals 2 over y minus 9, and we now need to solve for y. So, starting off with what we got in step 2, we need to multiply both sides of this equation by the quantity y minus 9. That way, on the right-hand side, it'll cancel in that denominator. On the left-hand side, we're going to pick up a y minus 9 term. Now, in this next little step here, I've skipped one step and just kind of condensed it all into one. I distribute the x to y and to the -9. That way I'll have an equation like xy minus 9x equals 2. Then I'm going to just simply move the -9x to the right-hand side. So that's what I meant by condensing a couple of steps just down into one. I'm going to be left with xy equals 2 plus 9x. Finally, to get y totally by itself, we're going to divide through by x on both sides and be left with y equals 2 plus 9x, all divided by x. Step 4, well, we've found the inverse. Whatever you find for y in step 3, you're just going to call it f inverse of x. So y equals f inverse equals 2 plus 9x all over x. Finally, step 5, which might be the other labor-intensive step. We need to compute f inverse of f of x and f of f inverse of x. And in both cases, we are hoping to get an x when we do so. So, f inverse of f of x. That means everywhere you see an x in the equation of f inverse, and look up here to step 4, that's where we have that equation. Anywhere I see an x in f inverse, I need to plug in the entire function f of x, which is why I've written 2 plus 9 f of x all over f of x. In this next equality, I've substituted in what we know to be f of x. You can look up to step 1 to figure out what that was. F of x is 2 over x minus 9. Okay, so then we have this whole fraction right here, and we have fractions within fractions. So to take care of that, I'm going to multiply by the quantity x minus 9 on the top and bottom of this fraction. Doing so is going to pick up an x minus 9 term on the 2. It's going to cancel out with this x minus 9 in this term, so we're just going to be left with 9 times 2. And finally, in the denominator, we're just left with the 2. And again, I've skipped a few steps here. You would distribute this 2 to the x and to the -9 so that the numerator would be 2x minus 18 plus 18. So I'm just simply left with 2x. Divide that by 2, and we get x. So that's half of the check. The other half is that we must compute f of f inverse of x. So that means in f of x, which we had in step 1, we need to substitute f inverse of x in for x anywhere you see x. And there's only one x that we see in f of x. It's just 2 over x minus 9. So for that x, I substitute in f inverse of x. f inverse of x we had found in step 4. It's right here. So I have 2 divided by a fraction 2 plus 9x over x minus 9. And this one's a bit easier to take care of. Instead of multiplying by x minus 9 on top and bottom like I did in our previous check, here I'm just going to multiply by x on top and bottom. Doing so will pick up an x term in the numerator, so I'm left with a 2x. But in the denominator, the reason why I did this is that the x in this tiny denominator, in this fraction within the fraction, the x's cancel, and I'm just left with its numerator, 2 plus 9x, minus 9x, right? Because I multiplied by an x on top and bottom, you got to remember that that x will distribute to both the fraction and the negative 9. That way in the denominator, 9x minus 9x will become 0, and we're left again with that 2x over 2, which is just x. And so since we found that f inverse of f gives us x, and f of f inverse gives us x, we have found the function's inverse. Thanks for watching, everybody.